All right, folks. Starting back where we left off, we were talking about subsets. And we want to be able to find the number of subsets we use a little formula 2 to the nth power. The n represents the number of elements in the set. If a set had 5 elements, 2 to the 5th power means you would have 32 subsets. To find the number of proper subsets, that's just 2 to the n minus 1. And that kind of makes sense. You got all the same number of elements, number of subsets, except for the one that has all the elements in the set, which is minus 1. So if we had a set 1, 2, 3, and we wanted to know the number of proper subsets, that would be 2 to the 3rd power minus 1, which would be 8 minus 1, or 7 proper subsets. Again, the reason there's only one less is because you take out the set with all the elements in it. Now this is just finding the number of sets. That's how you find the number of sets. To find the actual sets, well, we have 3 elements. So if I wanted to find all the subsets, that means I would have 2 to the 3rd power, or 8. I need to find 8 subsets to find them all. So if I listed all the elements of 1, that means I would have set A, I would have set B, and I would have set C. In other words, I would have a set where I'd have each element only listed once. That is a subset of that original set. And then I would look for combinations of 2 elements in the set. So I'd have a set with A and B. I'd have a set with A and C. And then the last combination is the set with B and C. Well, that gives me 6 of the 8. What else is left? Well, the set itself is a subset. Well, that's only 7 sets. So what is the 8th subset? If I'm trying to find all the subsets, what is the member of all the subsets? The empty set. We include the empty set in our list of subsets. So that gives us the total of 8. 1, 2, 3, 4, 5, 6, 7, 8 for our total of finding all the subsets. So not only do we want to know how to find the number of subsets, but we want to be able to find the actual subsets. Now, sometimes we want to be able to go backwards. Suppose we were told that we had 64 subsets. How many elements in the set? What would we do then? Well, we take our little formula, 64 equals 2 to the n. Well, because this is base 2, I could do the square root of it. But if you didn't know the square root of it, you could divide 64 by 2, and you get 32. Divide 32 by 2 again, and you get 16. Divide 16 by 2 again, and you get 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. How many times did you divide? 1, 2, 3, 4, 5, and count the last one, which is 6. So that means there were 6 elements in the set. Okay, if I had 127 proper subsets, how many elements are there in the set? Again, this is a working backwards problem. So 127, taking my little formula, 2 to the n minus 1, what will I do first? I will add 1 to both sides. So I get 128 equals 2 to the n. And then I will do just like I did up here. I will take 128 and divide it by 2. That's going to give me 64. And then I keep dividing out, and that's going to give me 7. I'll get 7, so it's going to be 7 elements in the set. So I'm just going to put dot, dot, dot here, keep dividing out, and it will turn out to be 7 times. All right, let's just summarize with some rules for sets to be sure. We've kind of gone over them. But I want to be sure that you know to follow these rules when you're using sets. We talked about this. We use capital letters. To name sets. Lowercase letters for elements. That is a general rule. That is not an absolute rule. We use the braces around the set. Not parentheses or brackets. Sets can be infinite or finite. Now, what's the difference between infinite or finite? Infinite means they go on forever. Finite means they stop, which means you can count them, how many there are. Be sure you're using the 3 dots, the ellipse, when you're trying to show the infinite set. That should be included in your set. Also, for the sake of time, if you have a pattern within your set, you can do like 3 numbers, then use your ellipse, and then finish your set. Always use your comma to separate your items in your set. Okay, we can use this line to negate a symbol. So we have a member of, not a member of, subset of, not a subset of, proper subset of, not a proper subset of. So you can use that line to negate a symbol. This is the last one. Review your number groups like integers, whole numbers, counting numbers, natural numbers, etc. If you have your textbook, they are on page 48 in your textbook. If you don't have a textbook, you might want to look these number groups up just to refresh your mind about what goes in what. Which one has zeros, which ones don't have zeros, which one has positive numbers, which ones don't have positive numbers, things like that. All right, that finishes up your first lesson on sets. Does anyone have any questions on anything we've gone over? Our second lesson is very short, and we're going to do it today also. Any questions before we move on? Okay. All right, lesson 2. Lesson 2 deals with operations that you can do with sets. So I'll first give you the operations, and then we'll look at some examples. So we have a complement, complement is denoted as the name of the set with a little apostrophe. Now, if you happen to look online at other videos or other textbooks or whatever, you may see the complement written a little bit differently. Sometimes they'll use a little C up there at the top. Sometimes they write it a little bit differently, but how you do a complement is still the same, but that notation may be just a little bit different. When you're finding the complement, that means that you're finding the set of all elements in the universal set that are not in the given set. Actually, let me go ahead and do the example with it. It makes more sense to do the example with it. So we have the universal set. A, B, C, D, and E. We have set A, which is C, D, and E. And we want to find a complement. So in order to find the complement, we go back to the universal set. What elements are in this set that are not in this set? So that would be the A and the B. So the complement would be all the elements that were in the universal set that were not in that particular set. The next operation you need to be able to do is the intersection of sets. That is denoted as a upside down U, B. So you have to have two sets to look at an intersection. So when you're looking at the intersection of two sets, you're looking at what is in common between the two sets. When there are no elements in common, we call the sets disjoint. And disjoint means it would be the empty set. When you see something written verbally and we're talking about intersection, we're going to be looking at the word and connecting the two sets. So we have set A, 1, 2, 3, 4. We have set B, 2, 4, 6, 8. And we want to find A intersect B. What is in common between set A and set B? That would be the 2. What do they both have in common? Would be the 2, 4. We have the union of sets. This is denoted by a, looks like a U, B. Again, we have to have two sets. So we're going to combine the elements of the two sets. But if we have elements that repeat, we only list them one time. Because just like when we were counting the cardinality, even though they repeat, the cardinality only counts it once. So when we are officially writing the set, we should only write it one time. When we verbally describe the union of sets, we're going to use the word or. Because we're talking about either set. So we have set A and we have set B. And we want to find A union B. So we can take all the elements of A and then add all the elements of B. But as we're adding B, we had an element that repeated, so we don't add it twice. And that is the union of our sets. Difference of sets denoted A minus B, so it kind of looks like a subtraction problem. So how we do it is a little bit different. When we're looking for the difference of a set, we're looking for the elements that are in the first set, the first one listed, that are not in the second set listed. So we have set A. We have set B. And we want to find A minus B. So what's in set A that's not in set B? That would be the values 1 and 3. If we had set C, which was 1, 5, and 6. And we wanted to do A minus C. Does it matter that C has some elements that aren't in A? No, it doesn't. We still are looking for what's in A that's not in C. So what's in A that's not in C? That would be 2, 3, and 4. It doesn't matter that C has 5 and 6. That's irrelevant. What is in A that's not in C? Difference of sets. So we basically have 4 operations. 3 of them require 2 sets. 1 of them only requires 1 set, really, and the universal set. So difference of sets. Subtracting what's in one set that's not in the other set. The union of set means we combine them together. Do not write repeated elements, but once. Intersection, we're looking for what's in common between the 2 sets. We use that term disjoint. If they don't have anything in common, it is the empty set. When we are using intersection verbally, we look for that word and to tell us, to indicate its intersection. Verbally for union, we're looking for that word or to tell us it is a union. And then for complement, that means that we're looking at the universal set. What's in the universal set that's not in the given set? So 4 operations: complement, intersection, union, and difference. Those are the operations that you should be able to do with sets. Now, I will be posting some problems on Brightspace or in Google Classroom. I'll let you know which place I'll be posting them for you to practice what we've gone over today. There'll be a set of practice problems for you to turn in, and then there'll be a quiz for you to do for a grade. So those will be some things that you need to be watching for in terms of assignments to do. And then we'll have class on Thursday. If you have any, remember, if you have any technology issues, you need to be sure that you're contacting the tech help in Bassett Hall. And if you have any questions about class, be sure that you're contacting me. I'll help what I can. Okay? Any questions before we sign off today? Okay, don't forget about the syllabus quiz that's due tonight. All right? See you, folks.